if you have plotted your GeoPandas data and it appears in the wrong place or does not line up with other layers, there is a good chance it is a CRS problem, or what we call a coordinate system problem. Now you can see from my base map, I have essentially plotted the map of Ghana or the regions of Ghana, and it's telling me, you know what, Ghana can be found in Nigeria, and that doesn't make sense. I also try to plot the capital cities of every region, and it tells me, those capital cities are found actually in the sea. That doesn't make sense. And I'm sure a lot of you would have been facing similar issues. You plot your points and the points fall no at nowhere, maybe in the sea, or they fall at a very small square. Or your polygons, like in my case, are falling in a completely different country or different region. This is simply, it's a simple problem, but a common one, and it has to do with your coordinate referencing system. So in this video, I'll show you how you can probably change the CRS of your GeoPandas data using the to CRS and how to match the layers to the same system. And if you stay with me to the end, I will also show you how I add this base map to the plot to make it more contextual. Remember, this video is not about how to add base maps, but it's just something I'll probably be doing at the end of the video. So if you want to see how to do that, then let's go together. So, okay, so first, what we'll be doing is I am going to import my GeoPandas data frame or my geospatial data. I have two layers in this case. So let me clear this map for now. So we have a clear fresh page. Just okay. So what we're going to do is we're going to import our geospatial data set onto Python. I've already recorded videos on that. So if you want the details of it, you can just refer to my previous videos, and you can see how that is done. But I have a geopackage file, which is in a particular coordinate referencing system, and I have a polygon file, which is also a shape file, and it's in a different coordinate referencing system. But let's confirm. Let's start by importing them. I'll start by first getting the libraries. I need GeoPandas. You need GeoPandas. So if you don't have it, install GeoPandas on your environment. Pip install GeoPandas should get you there. So I'm going to import GeoPandas as GPT. And I know I'll be using matplotlib for my plotting. So I'm just going to say from matplotlib, import pyplot as plt. I'll need this for my plotting. Eventually I'll show you eventually how to add a base map once we've been able to fix this first problem. So for now, let's deal with the first issue, importing the data onto just going to go ahead and close this. So we're going to deal with the first issue, importing the data onto Python. Okay, so I'm going to probably import my polygon data first. So this allows me to import my first data. I can also import my second data, which is the points. With this, we've been able to import the data set. Now, when you're working on GeoPandas, especially with multiple libraries, you need to always make sure that your data or your library, with multiple layers, you need to make sure that your layers are all on the same referencing system. Otherwise, you're going to have issues as I showed you earlier. So we can start by simply checking the coordinate referencing system for each layer. So if we do polygon.layer.crs, what you're going to get is going to tell you the coordinate referencing system. It tells you that this is a projected coordinate referencing system. UTM zone 13 of is from WGS84, but it's projected. Okay. We can also do the same for the points.crs. What does it tell us? It tells us this is a geographic coordinate referencing system with EPSG code 4326. This is the geographic coordinate system. And And so you can see that we are dealing with two different things. For clarity's sake, I'm just going to print both of them, right? So that we're on the same page. Some difference, so we can see the difference. So the polygon has EPSG 43. The polygon has EPSG 32630, and the point has EPSG 4326. This tells you that you are dealing with different systems or different coordinate referencing systems. And so what you usually want to do is to make sure that your data is on the same page. You either convert the polygon to the referencing system of the point, or you convert the point to the referencing system of the polygon, or you choose an independent referencing system or an independent EPSG and bring both of them to that page. Make sense? So that's what we're going to do. I'm going to first start by showing you two approaches. I always like to work unless I know I'm doing any kind of distance-based analytics, I like to work uh, in the graphic system, latitude, longitude, because that is a bit general. Okay, in fact, that's the whole purpose of working in geographic coordinate systems. So I like to work in 4326. That is the geographic coordinate system, GIS 84. This keeps everything simple. Unless you need to do any kind of distance-based calculation, then you can take it back to a projected system and perform your analysis. But for the purpose of this video, you can choose any referencing system you want. And I told you, you can always check these out from EPSG.io. Just put this on your website, and it's on your Google browser, and it's going to take you to a website where you can see which EPSG code works for your country, and then you can always bring all your layers to that particular code. So let's proceed. Now we know that we've imported the data, we check their referencing system, we see that there are different information or there are different referencing systems. So the next step is to bring them all to the same referencing system. In this case, I'm using EPSG 4326. Make sense? Okay. So this is what we're going to do. I'm going to reproject. It's called reprojection. Okay, so I'm going to say reprojected points or points reprojected, just so to keep the names consistent. Reprojected equals to, obviously the points are already in EPSG 4326, but just so you don't get confused, I'm just going to say points dot to CRS. Then I pass in this code, my EPSG code, like this. Or, if you want to stay old school, you can just hard code it 4326. But it's good to have a single point of reference, like a variable that stores the EPSG reference code you want to be using, and then you can pass it to any projection you're doing. Same we can do for the polygon. Polygon start to CRS EPSG code. Did I get this right? Polygon. Okay, I actually intended to spell it with S, so let's correct that. Polygons. Good. So now what we just did was we made sure that this point has the right referencing system. This polygon has the right referencing system. So now they are both talking on the same page. They are both on the same page. And now that they're both on the same page, you can now proceed to plot both of them. So let's see. In order to plot, it's good to create an axis, right? So you can keep both of them on the same plot. So I'm going to say figure axis equals to plt dot. So I'm going to use subplots, and I'm just going to pass in a figure size, right? Just to keep everything simple. 6 by 6 should be enough. And then I'm now going to plot the reprojected points, right? Remember, we are working with WGS 84, so I'm just going to plot reprojected points. Plot like this is how you plot point a GeoPandas file. Then you pass in your axis, okay? This axis here, this here. Now, if you don't know how to work with subplots, I will be recording a video on that. plt.subplots. If you don't know how to work with them, if they get you confused, I'll be recording a very short video on that. So you can stay in touch by subscribing and follow my video, and let me know what else you want me to record videos on, and I will be happy to do that in the coming days. But that's it. We've basically plotted points on the same axis. For now, we can show for now until let's show, then I'll show you how to plot the polygon as well. So we have the points. You can include the polygon as well. Polygon, yeah, that spelling is too long, so I'm just gonna take the plot also on the same axis, right? Yeah, in this case, the polygon is on top of the point, so you have to bring the points down so that the polygon is down, then the points are up. It's just a simple layer. What do we have here? Okay, yeah. So it wasn't visible because it's blue in color. I mean, if you check, you realize that the polygon is blue. It automatically takes blue as a color. So we would have to give this a different color. Just going to add color to the points, right? C equals to red so that it's a bit more distinguished. Good. So we have the points and the polygons falling on the same place. Now, this is what you wanted. It's quite straightforward. Once you realize your coordinate referencing systems are not on the same plane or page or reference system, what you do is you bring them to the same reference system by either defining a single reference system and bringing them both to the same place, or I can show you a second approach to do that, and that is actually what I prefer to do most of the times. Instead of defining a hard-coded referencing system, you can just make it relative, right? So you can say, okay, I don't know what reference system exists for any polygon that will happen in the future, and this is especially good for those who are doing automation. In that case, I would simply use something like this. Instead of hard coding it, I'll simply do polygons.crs. See? So it means that whatever coordinate referencing system this polygon has, apply it to the rest of them. And so once you run it, it's going to use the polygon CRS. And this is a projected system. Don't forget that. If you wanted it in the other way around, or the WGS84, you can use the point CRS, and then you would have that. So it's quite simple to do. I told you I was going to help you add what's it called base map to your data, right? So let's quickly do that. You can use contextually. Okay, so from let's just import contextually like this. Okay, as CTX. I like to import it as CTX. Others may import it as just simply CX like this. Here I'm going to run a bit fast, mostly because I'm going to take some time later on to develop a new video around how to develop or how to add base maps. So if you want to learn deeper into it, I can show you that in the next videos I'll be recording. So stay in touch. So import contextually as CTX, and then you're simply going to, remember we already have an axis, a figure and an axis down here. So we're just going to build on that. So what do we do? We simply create or add a base map, right? So ctx.add base map, and to what axis? We're going to add it to this axis here. Now you need to pass in the right coordinate referencing system so that it is also on the same page. So I'm just going to do CRS equals to, and remember we already defined an EPSG code up there, right? So I'm just going to pass this to it, and then PLT.show again. Minute. Oh, I already did a show here, so I'm just gonna hold up with that, and then it's always good to have both of them on the same page or on the same, so it doesn't get confused. But okay, so it's good to have both of them on the same page or on the same, so it sees them as one. So I'm just gonna run it now. And what do you have? You have a base map falling right at the bottom, and you can see that. Now let's give this polygon a bit of an opacity so that you can tell where it is landing or where it's falling. So at the place where we are plotting the polygon, I can just give it an alpha value. Alpha value of, let's say, 0.4, and that should help give it some form of transparency. So you can see that now Ghana is falling in Ghana. I mean, the polygons of Ghana are falling in Ghana, and the various points are falling at the right places. This is what you want to do when you're getting stuck with coordinate referencing system. Always think about reprojecting them. I hope this video was helpful, and leave a comment if you want to see more videos like this, or if you have any questions, and I'll be happy to answer them later on.